Today we will discuss about stacks. Stacks are linear data structures. It has a lot of applications in computer science such as subroutine calling, interrupt handling, etc. Okay. Actually, stack is a linear data type. That is, we can insert and remove elements linearly into the stack. And stack is otherwise known as a LIFO structure. What is a LIFO structure? LIFO means last in, first out. Last in, first out. That means the elements which are inserted last will be the elements which are removed first. Here we have elements we can insert like this. This indicates the top. Initially the top will be -1. That is, before inserting any element, the stack will be empty, and at that moment we will set a variable named top and we will set its value as -1. Initially we will set the top of the stack as -1, and when we have to insert an element into the stack, we will increment the value of top by 1. That is, we will increment the value of top by 1 and insert an element into the stack. After that we can insert next element, above that we can insert the other element. This is the way we will insert elements into the stack. Okay. And this operation, that is insertion of values into the stack, is known as pushing operations. Pushing operations. Okay. Whenever we have to remove elements from the stack, we will do another operation named pop. Popping means removal of data elements from top of the stack. That is, the element which was inserted last was 30 and the elements which we are going to remove first is also 30. This is how pushing and popping is done in a stack. Now let us discuss a real-time example. Real-time example of a stack. All of us know the CD rack. Whenever we are placing CDs into a rack, what we do? We will first place the CD. First CD will be placed, above that second CD will be placed, and above that third CD will be placed. But the CD which will be popped, which will be removed first, will be the third CD. Which one we will insert it last will be the first one to be removed. This is the way the stack operations are done. The next concept associated with the stack is size of the stack. Size of the stack means the maximum number of elements that can be contained in a stack. That is, the maximum number of elements that we can hold in a stack is known as size of the stack. Okay. We already said that stack is a linear data structure. So, we are going to implement the stack with the help of an array. That is, the declaration is int array 5. This means that we are going to store integer elements, that is, we are going to store numeral values into the stack, and the size of this stack is 5. That is, the array will appear like this. If 1000 is the starting address, first element is 5, then we are storing integer elements. So, the next address will be, or next location, next index will be 1002, next index will be 1004, next one will be 1006, 1008, 1010. This is the way by which an array is implemented. When it comes into a stack, what we do is we just rotate this array into 90 degree and keep it as a stack like this. That is 1000 location, 5, 1002, 10, 1004, 15 will come at 1004, 1006, 20 will come, then at 1008, 25 will come. This is the way in which we will implement a stack. Okay. And array will hold the starting address, that is starting address is 1000. So, this array, the first address placed in the array will be 1000. This is the way by which we are implementing a stack statically. Now, we will go for dynamic allocation. In dynamic allocation, we will use pointers. With the help of pointers, we will declare a stack like this. That is, stack contains pointer, the initial address will contain the address. That is, dynamically we will implement like this. Here capacity, we already said that there is a parameter named capacity or maximum size, that is the number of elements that can be contained in a stack, that we will declare with an integer variable capacity, and we will allocate space dynamically, that will we are allotting the storage space dynamically as int star calloc star calloc capacity comma size of int. That is, here the capacity is 5, that is we are going to store 5 elements and the size of int is 2. So, total storage locations or total size reserved for this stack is 10 bytes. This is the way a dynamic stack is allotted. Dynamic stack is allotted in this way, that is stack will be int star calloc capacity, where the elements are integers. So, total 5 into 2 10 bytes will be reserved for implementing the stack, and that will appear the same way. That is, first stack will contain the address 1000, that is here 1000 will come, then here 1002 will come, then here 1004 will come, then here 1006 will come, here 1008 will come, here 1010 will come, and the variables will be stored like this. Okay. This is the way by which the elements are inserted dynamically, or the storage area is reserved dynamically. Major operations associated with stack. The major operations associated with stack is first the creation of stack. We have already discussed the creation of stack, that is dynamically as well as statically. Statically with the help of arrays and dynamically with the dynamic storage concepts. And next operation we are going to discuss is pushing. Pushing, that is, pushing means inserting elements into a stack. One after other we will push the elements into the stack, that is by incrementing the top. Here in pushing we have to provide the element to be pushed. And next comes pop. In popping what we do is we will pop the topmost element from the stack, that is the top element, the element which is pointed with the top variable will be popped first. The next operation associated with the stack is traverse. Traversal means visiting all the elements present in a stack and displaying that elements. That is mean as that traversal is displaying all the elements present in a stack. Then we have to perform another two operations, that is full and is empty. Why we have to perform an full operation? Full operation is performed since we have to perform pushing. Why? We already specified the maximum size, maximum capacity of the stack, maximum capacity here we have reserved 5 elements, and if we are crossing the limit, that is if we are going to insert one more element into the stack, what will happen? It will result in overflow. Actually, why we have to go for an useful operation? Why useful operation is performed? Because we have to check whether the stack contains the maximum number of elements. We already specified that the maximum number of elements we are going to store in the stack is 5. Okay, so we cannot cross that limit. So before performing a push operation, we have to check whether the stack reached its maximum. If it reached the maximum, we cannot proceed further with our push operation. So we have to check whether the stack is full before performing a push operation. And next thing is empty. Why we have to check for an empty operation? Since if the stack does not contain any elements, we cannot pop any element from the stack. If the CD rack contains no CD, we cannot pop any CD from that. So likewise, if the stack is empty, we cannot go for a pop operation. So before performing a pop operation, what we have to do is we have to check whether the stack is empty. So these are the operations, and the last operation associated with the stack is size. Size means it will return the maximum number of elements present in a stack. Stack means the size of the stack. Okay, these are the major operations associated with a stack. Okay, this is our stack. We are going to perform pushing. How we will do pushing and popping, that we are going to discuss each element by each. Pushing means inserting elements and popping means taking removal of elements. Okay. Now we will discuss that is push of 10. Push of 10 means the element we are going to insert is 10. That is, first we have to insert a 10 into the stack and it will goes to the bottom of the stack. That is, now top is pointing to 10. Okay. Now you have to insert a 15. That is, already 10 is there and above that 15 will come. Okay. Now top is pointing to 15. Next we are performing that is a push of 30, push of 40 and push of 50. That is, already we have 10, 15 there and we are performing consecutive 3 push operations, that is push of 30, push of 40 and push of 50. Now our top is pointing to the topmost element 50. Now we are going a pop operation, that is we just call the pop function, that is when we perform the pop operation, the topmost 50 will be removed. This is how we will achieve pushing and pop operation in a stack. If we again perform a pop operation, what will be the result? It will contain just 10, 15 and 30. Both 40 will also be removed. Okay. Now pointing it to the top will be the 30. This is how, that is incrementing the top element, incrementing the top variable we will store, and by decrementing the top variable we will remove the elements from the stack. Creation of a stack is like this. We will first define a preprocessor directive, hash define. Usually in preprocessor directives the variable name will be declared as in capital letters. The variable names will be declared in capital letters. So, we are declaring the capacity as a preprocessor directive. So, in the preprocessing stage itself the capacity will get the value 5 and the stack will be declared like this, as we already discussed. It is an array and array will hold the value what 5. Whenever this information, whenever this instruction is executed, this 5 will come in place of capacity. This is the way we create a stack. Okay. Now we will discuss the pushing operation. We already said that the initial value of the top variable, that is our stack is empty now, no value is there. So, initial value of the top will be pointing to the value -1 and we will call the function as this, void push element. Why this element? Because we have to pass an element for the pushing operation. We have to store the element, that is we are going to store this element into the stack. So, we have to declare it as an integer and we have to pass, that is we are going to pass in a push operation. What we are doing is we are going to pass an integer value element into the stack. Okay. And what we said, before pushing an operation, before pushing an element, we have to check whether the stack is full. Okay. If the stack is full, we have to print an error message that we are not going to perform now, that we will discuss later. Otherwise, what we have to do, if the stack is not empty, that is currently nothing is there, top is pointing to something else like -1, the stack is empty, we have space, 5 memory spaces are there, we can insert elements. So, whether the stack is full? No, stack is not full. We can insert elements. Okay. In else part, what we do? The stack is not full, so we can insert element. Else part, what we do is we will insert this element. That is, the element is passed, and that element will be inserted into where? Stack of top. That is, we will increment the top value by 1. What is the current value of top? Current value of top is -1. When it is incremented by 1, it will be 0. That is, 0 means it points to this position. Okay. When it points to the first position, we will insert this element. That is, the element comes from this push operation will be inserted into the stack of top. Okay. And we can print that pushing operation is successful. This is the way by which we will insert elements into the stack. We will push elements into the stack. Now we will check what is full. Okay. Now, we will check whether the stack is full. That is, in this case, we have an if condition that we are not going to discuss now. We will come to else part. Whether our stack is full? No, it has spaces. So, we will come into this place and return 0. That is, we are returning a 0 to this point. That is, here in if part we are getting a 0, but so since a 0 is coming here, it will not, that is this if part will not work, and the control will go to this else part and the elements will be inserted. When will this stack is full? That is, look, first we inserted a 10, then a 15, suppose, then a 20 is inserted, then a 25 is inserted, finally a 30 inserted. That is, top is incrementing like this. Firstly top is 0, then top is 1, then top is 2, then top is 3, then top is 4. What does it mean? When top is 4, it means that it reaches its maximum capacity. That is, 4 means, what is 4 actually here? 4 is 5 minus 1 and 5 is our maximum capacity. When it reaches the maximum capacity, it means that we cannot move further. That is, we have to stop there. That is, the condition we have to check here is whether top equal to capacity minus 1. That is, if top equal to capacity minus 1, that is, if we reaches 4, it means our stack is full. Stack reached its maximum capacity and we cannot proceed further. At that moment, we have to return what? We have to return an 1. That is, that 1 will be come here. That is, this variable will contain a 1 here. This variable will contain a 1 here, and at that moment we have to print that stack is full and we cannot move further. This is the way by which a push operation is done in a stack. The next operation is pop. Pop is popping an element from the top of the stack. We can only perform popping operation from the top of the stack. That is, we have to pop an element from the stack. That is, now our element is like this: 5, 10, 15, 20 and 25. The topmost element contains 25, and when we perform the pop operation, we can pop 25 from the stack. First, as we already discussed, first we have to check whether the stack is empty. Whether the stack is empty? No, the stack contains 5 elements, so we cannot say that the stack is empty. So first we will go for the else part. Else part, what we do is we will pop the topmost element, that is, we will pop 25 and we will store it in the element, and we will decrement the value by 1. That is, we will decrement. Now top is pointing to this 25, and when we decrement the top value, it will point to 20. This is the operation done. Okay. After popping all the elements, that is, likewise we have decremented, we have popped 20, we have popped 15, we have popped 10, and after we have popped 5, what we will do? We will check whether the stack is empty. Now this condition is empty will be successful. That is, at the end of this popping operation, we will reach a situation that top equal to minus 1. That is, after 5, that is, in this position, top is pointing to, when top equal to 0, stack contains a 5. When this 5 is also removed, what will happen is, when we decrement the value 0 minus 1, what will contain? It will contain a minus 1. That is, top will contain a minus 1. That is, we can conclude that when top comes as top value, when the top value will become minus 1, we can stop the popping operation. That is, this condition is checked in is empty. That is, we have to check whether top equal to minus 1. If top equal to minus 1, what we have to do? We have to return an 1, and this if condition will be successful and we will return from the loop. This is the way by which we will perform a pop operation. Today we have discussed the major operations associated with a stack, that is pushing and popping.